Okay, Sec 4 A Maths mock exam paper 2. Question 1. Show that A plus B equals to ln 2. So in the first year, the company made a profit of $2,000. So N equals to 1. P will be equals to $2,000. Throw this into the equation. 2,000 equals to 1,000 e to the power of A bracket 1 plus B. So bring the 1,000 down here. So this becomes 2 equals to E A plus B. So since there's an E, right, what you want to do is ln both sides. So ln 2 equals to ln E A plus B. Okay, I'll write this a bit neater. Hold on. Okay, so what you can do is bring down the power to the side. Okay, so take note, ln E equals to 1. So A plus B equals to ln 2. Sure. Okay, part B, find another linear equation connecting A plus B. So they say that the second year, the company made $3,297 of profit. So this is what you want to do. You write down 3,297 equals to 1,000 e to the power of 2A plus B. So bring the 1,000 down here. So this 3.297 equals to E to A plus B. Okay, so ln both sides. Ln E to A plus B equals to ln 3.297. Bring the power down to the side. So 2A plus B ln E equals to ln 3.297. So 2A plus B equals to ln 3.297. So this is the second equation. Okay, hence solve the two equations from part A and part B. So you do a simple simultaneous equation. Okay, so write down two equations. The first one is A plus B equals to ln 2. That's equation 1. 2A plus B equals to ln 3.297. That's equation 2. Subtract the two equations. You'll immediately get A equals to ln 3.297 minus ln 2. Okay, so to retain the accuracy of the value, this is what I'm going to write. So this is basically ln 3.297 over 2, which can be written as ln 1.6485. I'll just leave it alone here first. So that's A. So what you want to do, sub A equals to ln 1.6485 into any equation that you prefer. So I prefer equation 1. So B, so from here, you know, B equals to ln 2 minus A, right? So just write ln 2 minus ln 1.6485. So B equals to ln 2 over 1.6485. So after you solve for A and B now, find the profit in the 10th year. So when N equals to 10, P equals to 1,000 e to the power of 10 ln 1.6485 plus ln, open a bracket, 2 over 1.6485. All you have to do is just type this in your calculator. You'll immediately get your answer, which is 179,816.9218. So round it off to 3SF, it's $180,000. Okay, so that's the end of question one. Let's move on to question two. The gradient at any point x, y on a particular curve is given by the following equation. The following equation is already dy dx. So the expression 1 over 4 at x squared minus 2 is all the expressions of the different gradients on the curve. The equation of the tangent at point P on the curve is y equals to x minus x plus 5. Okay. Okay. So if you want to visualize this question, right, to represent any curve, okay, you can just draw a simple curve like this. You don't have to be so accurate. You can label point P over here. Okay, so now there is a line that is tangent to point P. And this line is your y equals to minus x plus 5. Okay, so find the coordinates of point P. Okay, so from this line here, y equals to mx plus c, right? So which means your gradient is actually minus 1. Okay, so write down m equals to minus 1. So m of the tangent equals to minus 1, which means dy over dx should be equals to minus 1. So throw that into this equation here. So minus 1 equals to 1 over 4x squared minus 2. So bring the minus 2 over, you get a positive value. 1 equals to 1 over 4x squared, which means 4x squared equals to 1. X squared equals to 1 over 4. So you will have two values. One is x equals to half or x equals to minus half. Since the x coordinate of P is positive, we simply reject this. And you just write down when x equals to half, y equals to. So take note, point P also sits on the linear line y equals to minus x plus 5. So just throw it inside here. So it's 4.5. So the coordinate of P is half, comma, 4.5. Okay, part B. Find the equation of the curve. So your dy over dx equals to 1 over 4 x squared minus 2, right? Okay, so this is what I want you to do. You extract the 1 over 4 out, and then you write this as x to the power of minus 2, and this you just leave it as 2. So you're going to do an integration. So y equals to the integration of 1 over 4 x to the power minus 2 minus 2. Okay, so the integration will be 1 over 4. This will become x to the power minus 1, and then you bring the power down here. And this will become 2x. Don't forget your c. So now you can rewrite this as 1 over 4x minus 2x plus c. So we have the coordinate P, right? So throw it inside here. When y equals to 4.5, x equals to half. So throw inside this equation. Okay, so write this an improper fraction 9 over 2. It's the minus half minus 1 plus c. So 5 equals to minus 1 plus c. So you bring the minus half over here, it becomes positive half, 10 over 2, 5. So c equals to 6. So your equation of the curve is y equals to minus 1 over 4x minus 2x plus 6. Okay, question 3. The diagram shows a cross section of a hollow cone of height 30 cm and a base radius of 12 cm and a solid cylinder of radius r. Okay, so this one basically, right? When you look at it from like the front view, a cylinder, I know it's a curve, right? But when you look at it from the front view, you'll tend to see a rectangle. Although this part is curved. So it's kind of like an illusion, okay? So this rectangular portion here is actually curved, okay? So in actual fact, it's actually a circle here. That. Then we have the cone, stretches down here and stretches down here. This is the actual figure. When you look at it tilted outward side slightly, you can see the curve. When you are just looking at it straight head on, right, it will look like this. So take note. So I'll just leave this diagram here for now. Okay. So express H in terms of R. Okay. So how you want to do this, right? You have to apply similar triangles. Now, if you look at this triangle in particular, okay. So this highlighted triangle has a height of 30 cm and a base of 12 cm. And if you look at this triangle over here, okay, so I just draw this triangle out, okay? Then if you look at this one here, these two triangles are similar, okay? Because they have the same common angle and corresponding angles, okay? Okay, now for this big triangle here, this is 30 cm and this is 12 cm. And for this triangle here, it's 30 minus h. And this part over here is r. So we can write down 30 minus h over r equals to 30 over 12. Take note 30 or 12 is just 2.5. So you can just write down 30 minus h over r equals to 2.5. Bring the r over. So therefore, h is simply 30 minus 2.5 r. So we now have an expression for h in terms of r. Okay, so for part B, right, hence show that the volume of the cylinder is given by the following. So take note, volume of a cylinder is just pi r squared. This is a base area times the height. So it's just pi r squared h. So V equals to pi r squared h. So write down pi. Your r remains r squared. Now your h, right, is 30 minus 2.5 r. So multiply the r square inside because they want it to look exactly like this. So it's just pi bracket 30 r squared minus 2.5 r squared. Now they wrote the decimal as an improper fraction. So just write down 30 r squared minus 5 over 2 r. Apologies, r cubed. So r cubed. Okay. R squared times r should give you r cubed. So it's 5 over 2 r cubed. Okay, now let's move on to part C. Given that R can vary, find the volume of the largest cylinder which can stand inside the cone and show that in this case, the cylinder occupies 4 over 9 of the volume of the cone. Okay, so notice this is a 6-mark question. Okay, which means you have to do quite a number of steps, okay? So first thing, right, when you read this question, when they say find the volume of the largest cylinder which can stand inside the cone. So the volume that you got in part B is V equals to pi 30 r squared minus 2.5 r cubed. Okay, so it's kind of like a curve. All right. So which means your radius can vary depending on the value. And when it varies, right, the volume will reach a maximum value. So what's the maximum value? So what you want to do is find your dV over dr. So leave the pi outside, this becomes 60r minus 7.5 r squared. So it's just 60 pi r minus 7.5 pi r squared. So for you to have a maximum value, your gradient must be 0. Right, so take note, whether it's a maximum or a minimum value, the gradient will always be 0, right? So you let dV over dr be equals to 0. So 60 pi r minus 7.5 pi r squared equals to 0. So you can extract 7.5 pi r out. So this is 8 minus r equals to 0. So you can remove the 7.5 pi because it's just a number. So it's just r, 8 minus r equals to 0. So r equals to 0 or r equals to 8. Okay, so we reject r equals to 0 and we accept r equals to 8. Now, given that this is a 6-mark question, right, we just cannot straight away assume that, okay, r equals to 8 is the maximum value. For all you know, it could be also the minimum value. So do a test first. So you use your second derivative. So this will become 60 pi minus 15 pi r. So when r equals to 8, your d2v over dr squared will equals to 60 pi minus 120 pi, which is negative 60 pi, right? So this is less than 0, indicating that the value of r is the maximum value. So write your conclusion first. Hence, r equals to 8 is a maximum value, or rather gives a maximum value. Okay, then you start off by solving this part here. So find the volume of the largest cylinder. Which equals to pi 30 r squared minus 2.5 r cubed. The one that you got in part B. So this equals to pi 38 squared minus 2.5 8 cubed. So this should give you 640 pi. Next, volume of cone. 1/3 pi 12 squared times 30. That should give you 1440 pi. So cylinder occupies 409 of volume, right? Just take this over this, okay? So just write down 640 pi over 1440 pi should give you 4/9 straight away. So you can write down, sure. Okay, let's move on to question 4. Your left-hand side. Cotangent x is basically 1 over tangent x minus tangent x over 1 over tangent x plus tangent x. So tangent x itself is sine over cosine. So 1 over tangent x will be cosine x over sine x minus sine x over cosine x over cosine x over sine x plus sine x over cosine x. Okay, so what you want to do is turn this into one singular fraction and turn this into one singular fraction. So this will be cosine square x minus sine square x over sine x over cosine square x plus sine square x over sine x cosine x. Okay, so from here we can cancel the denominator out and you're just left with the numerator by the side. Okay, so from here you realize, right, cosine square x plus sine square x will give you 1. So you're just left with cosine square x minus sine square x. Okay, this one over here, we can now change it to right? So this will now become 2 cosine square x minus 1. Now take note, this is a double angle. From x, it becomes 2x. So you have to refer to your formula sheet, okay? So your formula sheet will tell you that this will equals to cosine 2x. And you just conclude saying that this equals to the right-hand side. Okay, so let's move on to part B. Hence, you're going to solve part B. So using part A, we just figure out that this is cosine 2x. So write down cosine 2x equals to cosine x. So remember the steps that we did, right? So before we got cosine 2x, we had 2 cosine square x minus 1 equals to cosine x. So bring a cosine over, this becomes like a quadratic equation. Right? So let cosine x be y. So this 2y squared minus y minus 1 equals to 0. So from here, factorize 2y plus 1, y minus 1 equals to 0. All right, so from here, y equals to minus half, or y equals to 1. So y is cosine x, right? So write down cosine x equals to minus half. Okay, over here, what you want to do is find the base angle first. So just write down cosine alpha equals to half. Just extract the positive value. So alpha is just cosine inverse half, which is 60 degrees. Now, if you observe, right, cosine x is minus half. So which means in your quadrant, it does not sit here and here. It sits over here and here, your two angles. So the first one will be 180 minus 60, which is 120. So x is 120 degrees. Then the next one, you reach the hypotenuse of the next triangle, 180 plus 60. So that is 240 degrees. Now on this side, cosine x equals to 1, right? Okay, so recall your cosine graph. Starts from here. This is 1, and this is minus 1, right? So 0, this is 90, 180, 270, 360 degrees. So when will you see 1 is when x equals to 0 degrees. And the next time we choose 1 is when x is 360 degrees. Okay, So write down your answers. X equals to 0, 120, 240, and 360 degrees. Question 5. Given that y equals to the following, show that dy dx can be written in the following format. Okay. So write down y equals to the following, so dy over dx equals to. So before that, right, this y, what you want to do is write down this as y equals to 2x plus 3 and 4x minus 3 to the power of half. So use the product rule. Leave this alone. Work on this. This half. 4x minus 3. This is minus half. Then you put 4. Plus. Now you focus on this. This will just give you 2. And this is 4x minus 3 to the power of half. Okay. So half times 4 will give you 2. So you can write down 2 bracket 2x plus 3 over 4x minus 3 to the power of half. Plus 2. So 4x minus 3 to the power of half, right, can be rewritten as 4x minus 3 over 4x minus 3 to the power of half. So the way, how do you see this is you can just multiply top and bottom with 4x minus 3 to the power of half. Okay, so when you do that, this will just become 4x minus 3. The numerator is 4x minus 3 to the power of half. So now we can just merge this into one singular fraction. So this is 4x plus 6 plus 8x minus 6 over square root 4x minus 3. So this will equals to 12x over square root 4x minus 3. State the value of k. K equals to 12. Okay, part B. A particle moves along the curve in such a way that the x-coordinate is increasing at a constant rate of 0.25 units per second. Find the rate of change of y-coordinate at the point where x equals to 3. Okay, so from here, x is increasing at this rate, right? So which means dx over dt equals to 0.25. Now create your equation. You want to find dy over dt. So dy over dt is dy over dx times dx over dt. Now that we know what is our dy over dx, right? It's actually 12x over square root 4x minus 3. And dx over dt is 0.25. Okay. So at the point where x goes to 3, right? So replace x with 3. So you might want to write down when x equals to 3. I'm going to write it, okay. When x equals to 3, dy over dt will equals to 12 bracket 3 square root 4 times 0.25. So this is 36 over 12 minus 3 is 9, square root 9 is 3. So this is 12 times 0.25, which equals to 3. Okay, part C. Hence, evaluate the following. Okay, so earlier on, right, we did y equals to 2x plus 3 bracket square root 4x minus 3. dy dx equals to 12x over square root 4x minus 3. Okay, so how do we solve part C is, and they use the word hence, right? Which means you have to use part A and part B to solve this. So part A, can you use part A to solve this? So do you realize this sort of resembles this? The only thing that's missing is a 12, right? So we can rewrite this as, okay, so write down. We can rewrite this as 12x over square root 4x minus 3. Take note, when you are multiplying 12, you have to balance it out by dividing it by 12. So another way to divide it by 12 is multiplying with 1 over 12. So outside, you put 1 over 12. So now it looks exactly like this. So you only have this to deal with, right? So the integration will be 2x plus 3 bracket square root 4x minus 3 bracket. Then you put the 7, 1. And don't forget your 1 over 12. So let the 1 over 12 be outside. You just put 7 inside here. Then you put 1 inside here. Subtract the two numbers. Then you multiply it with 1 over 12. So 1 over 12. Write it out for you. 2 bracket 7 plus 3. 28 minus 3 bracket. Then 2, 1, 3. 4, 1, minus 3. Then you close it. Okay. So this 1 over 12. So 17 bracket 5. Minus 5 bracket 1. So it's 80 over 12, which is 20 over 3. So answer to part C is 20 over 3. Okay, 6a, find the range of values of x for which minus 2 over the denominator has to be less than 0. So another way for the fraction to be less than 0 means negative, right? Okay. So notice that your numerator is negative. If my denominator is also negative, negative and negative give you positive, right? So how do we make sure that the fraction stays negative? So numerator is already negative, so denominator must be positive. So you can write down since the numerator is minus 2, which is less than 0. So just put bracket less than 0. The denominator must be more than 0 for the fraction minus 2 over 3x squared minus 8x minus 3 to be less than 0. So write down 3x squared minus 8x minus 3 has to be more than 0. Factorize this, you get 3x plus 1, x minus 3 to be more than 0. Okay, how do you solve this is, this resembles a quadratic function, right? So when I draw this graph, it's just a method to solve the question. This graph doesn't resemble any of this. It's just a way to solve this, okay? So I just mark out these 2 points. One is 3, one is minus 1/3. So for this to be more than 0, this part here, as long as more than 3 or less than minus 1/3, okay? So x has to be more than 3 or x has to be less than minus 1/3. Okay, B part 1. State the conditions for A and C for which y has to be more than 0. Okay, so observe this equation here. So when I write my b squared minus 4ac, okay, so take note for this function to be more than 0, right? Okay, x or y. So you want this equation, this is a quadratic equation. It can either be this or it can either be this. Now, if I take the first scenario and I throw it inside here, it has a more than 0 means positive, right? So if I float this above, do you realize that this equation works when it's floating above x axis? Now, if I take this graph here and I put it over here, at some point when I stretch this down, some values of y will start to become negative on this side as well and this side. So which means it cannot be a sad face looking graph. It has to be a smiley face looking graph. So for a smiley face looking graph, the coefficient of x squared, which is a, it has to be positive, more than 0. Next, once your graph is floating above the x-axis, means it does not touch the x-axis, meaning there's no x-intercept. So recall your Emacs formula. So when you're solving it and you do not want any value for x, right, it means this discriminant that's sitting under the square root has to be a negative value. So square root negative won't give you any answer, right? So in inequalities, what is a negative value? It means less than 0. So a discriminant must be less than 0. Throw values inside, 3 squared minus 4 AC less than 0. So 9 minus 4 AC is less than 0. So AC has to be more than 9 over 4. So your two conditions are AC has to be more than 9 over 4 and A has to be more than 0. Okay, part 2. Show that the curve will never lie completely below the line y equals to minus x minus 1 for all real values of A except A equals to 0. So we do a simple simultaneous equation. So before that, there's a criteria for the constant. So y equals to A x squared plus 3x plus c, right? So since c equals to 1, your equation is this. Okay, you will do a simultaneous equation of this and the linear line minus x minus 1. So right now 1 equals to 2. So ax squared plus 3x plus 1 equals to minus x minus 1. So rework this equation, you'll get ax squared plus 4x plus 2 equals to 0. Now let's go and observe the discriminant. Okay. So b squared minus 4ac. Let's see what this value is. So this is 4 squared minus 4a2. So it's 16 minus 8a. Okay, so let's observe the two different criteria. What happens when a is more than 0 and what happens when a is less than 0? Okay, so if a is more than 0, okay, let's consider all the possibilities. So when x equals to 1, 2, 3, 4, okay, at some point, right, when x goes to 1, the discriminant is more than 0. When x equals to 2, the discriminant will equals to 0. Then when x equals to 3, 4, 5, 6, your discriminant will become less than 0. So for values where a is more than 0, right, the curve will either intersect the line or be completely above the line. Now let's observe what happens when A is less than 0. So starting with -1, -2, -3, -4. So for values where A is less than 0, right, the AA will become negative. So negative, negative will be positive, right? So which means the discriminant will always be positive. So right now when A is less than 0, 16 minus 8A will always be more than 0. Since the discriminant is more than 0, the curve will never lie completely below the linear line. So in both scenarios, you will never see a scenario where the curve is completely below the line. Okay, so therefore the conclusion is the curve will never lie completely below the line. Okay, so that's done. Now let's move on to question 7. Given that the equation is as such, using a suitable solution or otherwise show that in terms of m, one of the solutions of the equation is log 3 over log m. Okay, let m to the power y be x. So x minus 4 over 3 over x plus 3 over x equals to 0. Multiply the whole thing with x. So now you have x squared minus 4x plus 3 equals to 0. Factorize this, you have x equals to 3 or x equals to x minus 1 equals to 0. So this x equals to 3 or x equals to 1. Okay. So we let m to the power y be x. So now replace x with m to the power y. So what you want to do is log both sides. Log my equals to log 3. So y log m equals to log 3. So from here, y equals to log 3 over log m. So one of the solutions is log 3 over log m. For part 2, right, observe your solution. So one is log y equals to log 3 over log m. Your other equation is m to the power y equals to 1. So log m y equals to log 1. So y equals to log 1 over log m. In both cases, if your denominator is 0, okay, if your denominator is 0, there is no solution for y. Okay, so make sure you should adjust the value for m such that you cannot have your denominator to be more than 0. So the range of values for 7 part 2 is simply that m cannot be, m has to be more than 0. Okay, so log m. So if you observe your logarithm, right, log base 10, this value over here, right, can be any value, but it can never be negative as well. Okay, so one thing is your log m cannot be 0. Another one is this value here must always be positive. So m has to be more than 0. Okay, so how do you write it in words? You just write down that the base of your exponential function must be a positive number. So the logarithm of a negative number will be undefined. In part B. In a triangle ABC, AB equals to 3 plus 2 squared root 5. An angle ABC is 45 degrees. Given that the area of this triangle is as such, write your answer in the following format. Okay, so just draw a simple triangle here. A, B, C. So this 3 plus 2 square root 5, and this is square root. So this is just 45 degrees. Okay. So half AB, BC, sine 45 equals to 2 plus 5 square root 5, well, 4. Okay, so times 2 on both sides, you will simply get A, B, and B, C. Sine 45 is 1 over square root 2, or you can write it as square root 2 over 2. And then this side will be. Okay, so usually I write as 1 over square root 2, but I'm purposely writing this as square root 2 over 2 to just match up with the denominator over here. So from here, you can just extract the numerator out now. So AB, right? I'm not going to write it as AB now. I'm just going to write it as 3 plus 2 square root 5. Then BC, square root 2 equals to 2 plus 5 square root 5. Okay. Take the square root 2 and multiply into this expression here. So now you have 3 square root 2 plus 2 square root 10. Bracket BC equals to 2 plus 5 square root 5. So BC equals to 2 plus 5 square root 5 over 3 square root 2 plus 2 square root 10. Multiply this with 3 square root 2 minus 2 square root 10 over 3 square root 2 minus 2 square root 10. So now what we're doing here is rationalizing the denominator. Don't forget to rationalize this A plus B, you multiply it with A minus B. Recall your special product from set 2. So that when you get A square minus B square, the square roots in the denominator will be gone. So continuing on from here, now this would be 18 minus 40. That is 6 square root 2 minus 4 square root 10 plus 15 square root 10 minus 10 square root 15 over minus 22. So it's become 11 square root 10 plus 6 square root 2 minus 50 square root 2. So it's 11 square root 10 minus 44 square root 2 over minus 22. Okay, interact the minus above, so it's 44 square root 2 minus 11 square root 10 over minus 22. So all of them are multiples of 11. So you can write your final answer as 2 square root 2 minus half square root 10, which is in the same format as this. Okay, by the way, apologies, when you shift the positions of this two, right? This is no longer minus 22, it's positive 22. Take note. Okay. Take 8A. Express 3 plus 2 log A minus half log 4B squared. Okay, so this is log base 10, log base 10, right? So what you want to do is write down 3 is basically 3 times 1 plus 2 log A minus log 4B squared to the power of half. So 1 can be written as log 10. This can be written as log A squared. This can be written as log 2B. So this is now log 1000 plus log A squared minus log 2B. Now, this multiplied with this divided by 2B. So it's log bracket 1000 B squared plus 2B. Given that 2 log C3 equals to 7 plus 4 log 3C, find the possible values of the positive constant C. So we're going to work this equation with the log base 3, which means we will change this. So take note, log AB can be rewritten as 1 over log BA. We can flip their positions. So this becomes 2 bracket 1 over log 3C equals to 7 plus 4 log 3C. So let log 3C be x. So this becomes 2 1 over x equals to 7 plus 4 x. Multiply the whole thing with x. So this 2 equals to 7x plus 4x squared. This is 4x minus 1. X plus 2 equals to 0. So from here, x equals to 1 over 4, or x equals to minus 2. So log 3c equals to 1 over 4, which means c equals to 3 to the power of 1 over 4. Key this in the calculator, you get 1 over 81. Log 3c equals to minus 2. Please do not reject this because a logarithm can equals to a negative number. Because, always remember, log AB equals to x. This is always a power. A power can always be negative, right? So therefore, c equals to 3 to the power minus 2, which is 1 over 9. So these are your two answers. Okay, question 9. Find the radius and coordinates of the center of the circle. So this one, you just do completing the square. So it's x squared plus 2x plus y squared minus 9 equals to 0. This is x squared plus y squared plus 2y minus 9 equals to 0. Okay, so from here, this can remain as x squared. You want to complete the square for this one. So write down y squared is 2ab plus b squared, minus it off, then put the minus 9. So this part you can factorize out. So it's x squared plus y plus 1 squared minus 10 equals to 0. Okay, so center of the circle. So 0, comma, minus 1. The radius will be square root 10. Part B, find the equation of the tangent to the circle at P bracket 3, comma, minus 2. Okay, so let's go and sketch this out. So this is the center of the circle. So at the center is 0, comma, minus 1. So P should be somewhere diagonally down here, which is 3, comma, minus 2. Okay. To stretch this part out is the radius. Okay. So let's go and find the gradient of this line first. So the gradient of CP equals to minus 2 minus minus 1 over 3 minus 0. So it's minus 110. You want to find the equation of the tangent to the circle. Now recall the topic that emails, the tangent is always perpendicular to your radius, right? So the gradient, the product of their gradient will be minus 1, which means the gradient of the tangent at P is simply minus 1 divided by minus 1/3, which is just 3. So do a simple y equals to mx plus c, where y equals to 3x plus c, and throw in the coordinates inside. Minus 2 equals to 2 bracket 3 plus c. Okay, so from here, write down your linear equation y equals to 3x plus c. So when x goes to 3, y equals to minus 2. So put minus 2 equals to 3 bracket 3 plus c. So c equals to minus 11. So your equation will be y equals to 3x minus 11 plus 3y equals to k, where k is a positive constant, is a tangent to the circle. Find the value of k. Okay, so what you want to do is rewrite this as x equals to k minus 3y. Okay, so there's a circle and there's a point over here. All right, so then there's a line that's tangent to this point here. Okay, so this point here follows, I mean, it sits on this line, right? So it follows this equation. So when you go and read this equation carefully, when you write it like x equals to subject, what this means is when y equals to y, x equals to k minus 3y. So the general expression for the coordinate here is k minus 3y, comma, y. So this coordinate also lies on the circle, right? So the circle's equation is x squared plus y plus 1 squared equals to 10. So replace x with k minus 3y plus y plus 1 squared equals to 10. Okay. So what you want to do is expand this and then you simplify it. So you have to write it in the form of like ay squared plus by plus c equals to 0. So go and expand this out. You will get k squared minus 6ky plus 9y squared plus y squared is 2y plus 1 equals to 10. So bring the 10 over, it'll become minus 9, right? So it'll become k squared minus 6ky plus 10y squared plus 2y minus 9 equals to 0. So from here, try and simplify it, write it in this format here. So it's 10y squared plus, so it's 2y minus 6ky, right? So you can factorize y out, and it's just 2 minus 6k. Put the y, then you put the constant, k squared minus 9 equals to 0. Okay, so when you're doing the simultaneous here, you are expecting just one answer only, right? Which means your discriminant, therefore, has to be equals to 0. So it's 2 minus 6k bracket squared minus 4, 10, k squared minus 9 equals to 0. Okay, so from here, when you reduce down, you should get minus 4k squared minus 24k plus 3, 6, 4 equals to 0. So you divide both sides by minus 4, you should get k squared plus 6k minus 91 equals to 0. Factorize this is k plus 13 bracket k minus 7 equals to 0. So therefore, k equals to minus 13 or k equals to 7. Since k is a positive constant, we simply reject minus 13 and we accept this as the answer. Okay, question 10. So this line here is 17 kilometers, 7 km, Go and find what's AD and CD, and then you add up the perimeter, okay? So this part here gets a little tricky. What you want to do is you draw a dotted line here first, okay? And then you want to call this as X. All right? Okay. So let's go and find what is AX, all right? So cosine theta is adjacent over hypo. So write down cosine theta equals to AX over 17. So therefore, AX equals to 17 cosine theta. Okay, so next part, right, is actually over here, okay? So I'm going to still call this XD. This line here is the same as XD, right? Okay, so what I'm going to do is I'm going to show you how to do this part here. Okay, I'm going to call this angle as Y, all right? So this is a right angle triangle. So 180 minus 90 is 90 degrees, correct? So 90 degrees is made out of theta and Y, correct? So if I take 90 minus Y, I'll get theta, correct? So if I look at this part, this angle here is 90. So 90 minus Y gives me theta. So in this case, if this is 90 degrees and this is Y, 90 minus Y should give me theta over here, which means in this right angle triangle, this angle here is also theta. So with 7 kilometers and a theta here, I can easily find XD. So on this side, from this angle, this is opposite this hypo. So I use sine. The sine theta equals to the length of XD over 7. So XD is 7 sine theta. So therefore, AD is 17 cosine theta plus 7 sine theta. Okay, how do we find CD? To find CD, the plan is to find BX and subtract it with. Okay, so let's create this point over here. Let's call this Z, okay? So I'll call this point Z. So take BX minus BZ. That's all I gotta do. So let's go and find BX. So opposite hypo. Sine theta equals to BX over 17. So BX equals to 17 sine theta. Let's go and find what's BZ. From this angle here, this adjacent, this is hypo. So cosine theta equals to BZ over 7. Cosine theta. So CD equals to BX minus BX minus BZ, right? So it's 17 sine theta minus 7 cosine theta. So now we can simply add up to find the perimeter. L equals to 17 plus 7 plus 17 cosine theta plus 7 sine theta plus 17 sine theta minus 7 cosine theta. This is 24. 7 plus 17 is 24. So it's 24 sine theta. Then 17 minus 7 is 10. So it's 10 cosine theta. Shown. Okay, so for part B, express L in the form of the R formula. So what you want to do is you just do the simple Pythagoras theorem of 24 squared plus 10 squared, you get 26. Then using the tangent, so use alpha equals to tangent inverse 10 over 24, you get 22.6 roughly. So your R formula will be 24 plus 26 sine bracket theta plus 22.6. Okay, part C, find the greatest possible value of L and the value of theta at which this occurs. Okay, so the greatest value of L will be 50. So basically, this has to be 1. The sine of the angle equals to 1. So 24 plus 26 would be 50. So this portion here has to be equals to 1, right? So write down sine of this angle equals to 1. So sine inverse is 90. So theta equals to 67.4. Okay. The total length of the route has been fixed to a distance of 40 km. Show that theta equals to 15.4. So just use the equation and equate it to 40. So from here, bring it down. Sine of the angle is 8 over 13. So it means sine inverse 8 over 13 will give you 37.98. Subtracted 22.6, you'll get theta equals to 15.4. Okay. All right. So that's all for the exam.